Welcome everybody to this session where we're going to talk about two brand new product lines at ETC. Again, my name's Chris Patton. I'm the Architectural Market Manager at ETC, and I've had the pleasure of working with an incredible product development team who have put together these groundbreaking new products. We've been working on Navis and F-Drive for about 18 months now, and it has just released and made its public debut only a couple of weeks ago. So all the information that we're about to talk about is live. It's available from our product pages on our website. And I think actually there is a brand new hero image, a big banner graphic at the top of the ETC homepage. And you can click on that and go and find as much information as you would like to see. But today we're going to talk in some depth about these two new products. And so we'll kick things off. We have an overview here of what Navis and F-Drive is. And these are, as I mentioned, two brand new product lines. So beginning with Navis. Navis falls under the ArcSystem banner. And ArcSystem, you may recall, has been a brand which has been in existence with ETC for a few years now. Originally was part of a product line from a company, GDS, in the UK, and through 2014 through about 2019, ETC were manufacturing ArcSystem product in the US, and in the middle of 2019 we acquired the ArcSystem family of products from GDS, so it became an outright ETC product. So that's the ArcSystem Pro line of product that we've been manufacturing for some time. And we today have developed and are talking about a brand new product line, which is going to fall under the ArcSystem banner. ArcSystem is what we're using as an umbrella brand for our architectural downlighting solutions. So ArcSystem Pro, still in existence, still manufactured at ETC globally now. And we actually have a great product line there, which is doing very, very well in many applications, particularly things like auditorium projects. ArcSystem Navis, a brand new downlighting solution, and it pairs with the F-Drive LED driver solution. We'll be covering these in sequence. So ArcSystem Navis we're going to talk about first and some of the options there and what you can do with the product. And then we're going to pause for a little bit of questions. And then we're going to move on to the F-Drive power solution, which you use in tandem with ArcSystem Navis to provide one cohesive architectural lighting solution. So I mentioned ArcSystem Pro in the past, particularly been used predominantly in things like auditorium spaces, but over time that's moved into other areas and projects as well, things like houses of worships. We've even seen quite a bit of use in large spaces like convention centers. ArcSystem Navis is good for use as a complementary product to those types of projects, but we also see this broadening out into other more commercial and industrial projects, things like hotels, hospitality. We have an image here of a hotel lobby that we see a typical installation for things like ArcSystem Navis to be used in. Here is a scene of a restaurant, a high-end restaurant. The nice thing about Navis and F-Drive is that the driver part of the LED luminaire is removed from the fixture itself, in that Navis has only the core technology that's required to make light come out the front of the fixture. All of the high-tech power supplies and driver electronics are located centrally into a central driver solution that is F-Drive. And we'll talk about that as we go through the presentation. But in an example such as a restaurant scene that we're looking at here, it makes it that you could install a luminaire into the ceiling, locate the centralized driver solution into an accessible electrical room or facility room, and easily make upgrades or changes or service projects without having to access the main public spaces. So Navis 100. 100 is a size identifier. It's what we've generically called the first. We do see this as the first of a new line of products. This is just the beginning, really, and we expect over time to add to the range. But Navis 100 is where we start with the ArcSystem Navis family. We're talking right now about the white and fade to warm version. Now, when we say white, we're not just talking about the fixture color. Obviously, we're looking at a white trim plate here. And at ETC, we're lucky enough to have a full paint line in our facility in Wisconsin. So we can actually manufacture different colors of trim plates as well. Black, white, and a primed trim plate are all standard options. But if you wanted to do something custom, you know, maybe a red color to match a themed environment, or a pink color, then we can do that too. But when we say white, we're really talking about the LED color inside. And we have a range of fixed white LED options, and we'll talk about those in a few slides' time. Here's a section, a profile look of the fixture itself, and a few key points here with the Navis 100 luminaire that we wanted to call out. The first is physically, we're talking about a very small and compact luminaire here, less than 100 millimeters in height. And importantly, what we've done with this is engineer it in such a way that you don't get any light leak from the back of the fixture. This makes it really nice if you're installing it into architectural environments, such as ceilings with slatted ceiling panels or perforated ceiling panels. You don't want to be lighting up the industrial spaces, the electrical conduits, or air conditioning equipment from above. So we make sure that all of the light in the fixture, all of that energy is pointing out and down at the front of the fixture, and there's no light leak from the rear. We've developed a pretty innovative clamping system with the Navis 100 luminaire. It's actually controlled or installed from the room side. So the fixture itself fits into the hole in the ceiling, and we have 3 ceiling clamps that allow the fixture to be attached and clamped onto the ceiling itself. And we have a 2mm hex key, a 2mm Allen key that you use from the room side. And in winding the Allen key, it actually allows these clamps to flip out and wind down onto very small ceiling surfaces, a range of right down to 0.5 millimeters, and up to about, well, a maximum of 20 millimeters. That's about 3/4 of an inch. We're using a new LED in this from the LumiLED, and it's actually up to about 1500 lumens in output, depending on the color temperature and the type of optic you have. And as I mentioned before, we're relocating all of that essential technology out of the luminaire itself into an accessible remote driver, which can be up to 100 meters away. That's about 330 feet away from the luminaire itself. That really helps when you're installing this into spaces where you just can't gain access to the luminaires themselves. If you need to get up to that fixture to clean it, to maintain it, then you can still do that, but it's very unlikely to fail because all of that essential technology is being installed remotely. RJ45 in and through connectivity, we're utilizing a globally familiar cable type, cable infrastructure here. We actually promote the use of Cat6 cable. And that does not mean that this is a PoE fixture. It is not a PoE fixture, but it uses the same type of cable to carry the power from the driver solution, F-Drive, that we'll talk about shortly, from the remote location up to the luminaire itself. And you can see an RJ45 in and through, and that allows us to daisy chain up to 4 of these Navis 100 luminaires per circuit. We've made things very modular with Navis 100. What we have done is made it so you select the type of LED you would like to see, the color temperature of LED you would like to see, and then you choose the beam angle. You have the option to choose a different optical accessory, and then you have an option to choose the trim plate that fits on the front of the product itself. But all of those parts are completely modular. They are field changeable, and they're very easy to assemble. So you can obviously order a combination of product from ETC, and it will be assembled, built and assembled to order as you would like it to be. But if you get this thing installed in a particular location and you think, you know, I really wanted a 25-degree optic instead of a 40-degree optic, I want to be able to change that, you can just do that in the field itself. So we've got a short video here throughout this presentation. There's a series of videos. Hopefully they're streaming okay and they're not too stuttery, but this will give you an idea of how the optic changing works. We have 4 optics, a 15, 25, 40 and 60 degree, and they simply, using this optic removal tool, it's a little suction cup, connects onto the optic itself, twists out of the fixture itself, and then you install the new optic in place. in the existing luminaire. It's as simple as that. This was done in pretty much real time. It's only a few seconds just to twist out an optic and install a new one. But that flexibility is really useful when you get to site and you realize things weren't quite as you needed in the original offline lighting design. You have the option to change those. In terms of mechanics of Navis 100, we have incorporated a 360-degree rotation option. So the only thing that's inhibiting that option is the cable itself that plugs into the fixture. Other than that, you can point and rotate the fixture wherever you'd like it to be. We also have a 30-degree tilt, and that 30-degree tilt does not break the ceiling plane. So you'll see as the fixture tilts, it has a chamfered edge on it, and that means that the leading edge of the fixture does not protrude below the ceiling itself. It doesn't break the ceiling plane, and that makes it a really nice, clean look. The pan and the tilt are also lockable from the room side, again using that same 2mm hex screw that we use for the ceiling clamps. That allows you to lock the pan and the tilt in place in exactly the place you need it to be. Even things like minor building vibrations are not going to break that. It locks it really tight. We have a series of optical accessories that can snap into the front of the fixture using a plastic tab connectivity. And so you've already inserted your primary optic that we saw in the last video clip. And what we have now is another video clip to show you how the optical accessory just clips in over the front of that. If you don't use an optical accessory, we have a finishing ring. It snaps into the front of the fixture just like this. And what this does is hide those plastic tabs I was just talking about. So if you just want the core fixture itself with an optic and you want a nice clean finish look so that the finishing plate goes in on the top, the trim plate goes on the top, then you can do that. Failing that, the first option we have is this Solite accessory. So obviously that finishing ring would not be in place there. You would just snap the Solite glass in over the front. That provides a nice soft diffusion. We also have a frosted optical accessory, which provides a much more dense diffusion, a much heavier frosting, less transparency, much more even softer diffusion. We also have a linear accessory. The linear accessory is great if you're lighting a hallway or a corridor and you want to spread the lens, spread the light along that hallway. And you also have the option of double stacking accessories together. So we also have a hex louver, which is great for reducing glare. And if you wanted to combine that with something like a Solite glass, so you've softened the light coming out the front, but you also want to reduce glare, you can do that too. Then on the top of that, the trim plate pops over the top and is magnetically held. Well, more on that one in just a couple of slides' time. So here's a quick look at the range, the different trim plate options. We've already inserted our primary optic. We have the option of putting in our secondary accessories, our secondary optical accessories, and maybe a hex louver for glare control as well. In addition to that, we then want to place a trim plate over the front to finish the look of the luminaire itself. And we have a few different trim plate options. The first trim plate we have is a standard trim plate, and that just finishes the look of it and pops on and magnetically holds over the front of the luminaire itself using 3 strong magnets. The second one is a pinhole, just a much lower glare from the front of the fixture. We have an offset, which is kind of like the pinhole, but elongated. So if you want to tilt the fixture, you can do that and not lose any light coming out. Then we have a curve trim plate, which really makes the blends in the front of the fixture and lets it glide in from the ceiling space itself. And finally, we have a wall wash accessory as well, which converts the downlight that we've been looking at so far into a really nice wall wash. Trims it off across to the top of the ceiling space and looks really good. The wall wash accessory again is magnetically held. It actually is provided with a template which presets the tilt angle of the luminaire itself to just the right tilt angle that we need in order to use the wall wash accessory. We then lock that tilt angle in place using the pan and tilt lock with a 2mm hex key. And then we magnetically hold in the wall wash accessory over the top. The wall wash accessory is designed as a 2-to-1 optical spacing. That means a 3-foot setback from the wall on 6 feet centers, or you could go 2-foot setback on 4 feet centers. And that really, when you're at 2 foot versus 4 foot, it actually gives you a really nice clean wall wash without scalloping on the wall at all. The wall wash accessory is designed to fit all Navis 100 variants. It will fit the white, it will fit the fade to warm option. There's no difference in the type. You don't need one for a white version, one for a fade to warm version. Color temperatures are available in 5 different fixed options. 2700 Kelvin is the warmest, 5000 Kelvin is the coolest. We found over the last few years that these 5 color points are the most popular in terms of most projects, and they also match the ArcSystem Pro fixed color temperatures as well. So you can combine fixture types between ArcSystem Pro and ArcSystem Navis, and you're going to get a very similar appearance in imperceivable differences really between the 2 different fixture types if you choose to do that in the same space. We're actually using a brand new LED range from luminaires for Navis 100, all very high quality. The 5000 Kelvin actually is at a +80, but the 4 color temperatures in the warmer part of the spectrum are +90 CRI. We also published TM30 statistics on all of our LEDs, and they're available on the data sheet. You can download that today. In addition to the fixed white color points, we also have a fade to warm option. This is a 3000 Kelvin fixed white, but as the fixture fades down to 0, it warms up the color temperature to 1800 Kelvin to mimic that incandescent redshift that you would see when using a tungsten luminaire. It's a feeling that is often preferred in auditorium type applications or places where you have a warmer aesthetic, somewhere with the use of plenty of wood, or somewhere where you just want to provide that nice redshift warm feeling. In addition to the fade to warm technology in the luminaire, we've actually added an option in the F-Drive component as well, the centralized driver component that we'll discuss in more detail later. But that provides the option of something that we call fade to warm temperature scaling technology, and that allows you to adjust the point in the intensity curve where the fade to warm completes and it meets its 3000 Kelvin finishing color temperature. That'll make more sense as we talk about the F-Drive component as well. But FTW temperature scaling allows you to match up the profile, the fade to warm profile, when you're using it with other types of luminaires as well. And that's a really useful tool. Or if you just want to amend the dynamic of the fade to warm, maybe in a daytime type scenario versus a nighttime type scenario, and change that on the fly, you can do that too. Another short video here just demonstrating fade to warm. You can see as the 3000 Kelvin fades down, you get that really nice warm, rosy feeling as it shifts towards the red part of the spectrum, down to 1800 Kelvin. It's a bit clearer here when we see the non-fade to warm versus fade to warm side by side. You see it start off really warm on the right luminaire, and as it gets up to full intensity, the 2 are indistinguishable. And again, back down the fade curve, nice smooth fading. Some of the video streaming might not be fading so smooth here, so forgive the streaming quality, but these images and videos are all available to view on our website as well, and you'll see it much smoother if it's not working as well here today. So we've talked about Navis 100, the different components of the product, and we've used the Navis 100 white LED and fade to warm LED. But one of the most consistent pieces of market feedback we've had since we really launched ArcSystem Pro 5 years ago at ETC has been to add the option to have a color changing architectural downlight. And I'm pleased to say that we have now achieved this with Navis 100. Not only is it available in the fixed white color points and that fade to warm option, but we have a full RGBW color changing variant of Navis 100. And the most important thing about this is aesthetically, the luminaires look identical. The only thing that changes is the LED array inside the fixture itself. So again, we have another short video here just to show you some of the details. We have leveraged our knowledge of our entertainment color changing luminaires and created an architectural product using that same knowledge. It connects and looks just like the fade to warm and fixed white, installs into the ceiling using those 2mm hex keys that we were talking about earlier, and connects using the Cat6 cable back to the F-Drive driver remotely. Again, up to 4 of these on a circuit. The first thing to note is that we've produced a calibrated 3000 Kelvin color point on this, which looks identical to when you use the 3000 Kelvin fixed white version. But obviously with the full RGBW array in it, we then have the option to push into those nice saturated colors as well. So this is us using an echo touch with some fixed color points and how the luminaire responds to that. We are using fully calibrated arrays with Navis 100, and that is pretty unusual in architectural products, but this means that you're going to get that same consistency when using multiple luminaires, the same color aesthetic, the same appearance from fixture to fixture when using multiple luminaires in the same project, or even adding luminaires to an existing project. The other thing we add to this is thermal droop compensation. That again comes from our entertainment side, means that as the luminaire warms up, it means the intensity is going to be maintained. You're not going to lose the intensity as the arrays warm up with that thermal droop phenomenon that you get in LED technology. We also apply active power budgeting to this. Again, this is something from our entertainment side. We've been doing it for many years with things like our Source 4 LED product and color source. And what this means is it allows the most amount of power to be pushed through individual colors as it does when you have all of the color chips on at the same time. So imagine we have up to 22 watts of power. That's the most we can have when all 4 types of LEDs are on: red, green, blue, and white. But you actually only want red on at any one time, and that means rather than have a quarter of the amount of power available, that we can actually push more power and divert more power through to the red chips to allow the intensity easy for me to say, the intensity to be as bright as it possibly can, just in that red color. So that's what active power budgeting does. The fixture itself dynamically works this information out. It has onboard algorithms to deal with this. It's a very clever technology and allows you to maximize the look of your design without having to worry about intensity levels falling away. Again, the most important thing is it's a common look and aesthetic, and all of the accessories that we were previously talking about, such as the optical accessories, the trim plates, the different primary optics with the beam angles, they all fit the RGBW as well. So one type of optic, one type of trim plate will mix and match all different types, all of the types of Navis 100 luminaire. That's great from a service and maintenance point of view. You don't now need 60 different variants of a luminaire because they have slightly different requirements of beam angles or slightly different trim plate from room to room, space to space. You can now just have individual buckets of parts during an installation, or even just as maintenance for an ongoing purposes after the fact. So a couple of example layouts here. The first layout we're going to take a look at is a very small room, just to give you an idea of what happens when you put 4 fixtures in a space. We've put the measurements here in both metric and imperial. This is a global webinar. There are people from all over the world listening, and I know some people prefer feet and inches, some people prefer meters and centimeters. So we've done both kinds here. This is a 10-foot by 6-foot room, very small, at a 9-foot trim height, and the intention really is to show you how many luminaires we need to get up to about a 32-foot candle. That's 344 lux average light level. So in this case, 4 fade to warm Navis 100s will give you that in a nice even coverage using the 60-degree beam angle. By contrast, if we go into a much larger room, a 60-foot by 40-foot room, 18-meter by 12, and a 16-foot trim height, and we use 48 Navis 100, 2700 Kelvin fixed white luminaires, then we're actually seeing about the same light level, 31-foot candle, 334 lux. And we've produced these layouts using AGI 32. It's a service that in the US our field project coordinators can help with. I know that many of our reps as well provide this service. So if you're interested in assistance with layouts, then we can help point you in the right direction with that if you don't have the in-house resource to do it itself. Well, what happens when recess is not right? We've talked about installing this product into a recessed aperture. Well, we also have a surface cylinder accessory that you can take the luminaire and install it into this metal surface cylinder can, and that enables you to convert the recessed product into a surface mounting luminaire. This adds a complete new style to the product, and again is pretty unusual in architectural lighting. You normally either have a recessed fixture or a surface mount fixture. Very unusual to have one that can be converted into the other. And so we've done this just by making a series of accessories. This will allow you to install the Navis 100 straight onto a junction box using US standard hole sizes or even a UK standard hole size. And we've even made room to drill in your own hole sizes as well, if that is easier for you, depending on where you are in the world or the type of application you may have. In addition to the surface cylinder, we also have a pendant kit as well. So that's kind of like the surface cylinder, but has the canopy and the pendant stem. And the pendant stem allows you to internally run those RJ45, those Cat6 cables hidden inside the stem itself, just for a different style and neater appearance of the luminaire. So here's a quick video on the pendant accessory just to show you how this thing would install. Again, what we've done is pre-install two Cat6 cables here down the stem, just to make it easy to know which is in and which is through. It does matter which goes in where, so that's why we've used different color cables. The luminaire itself then inserts into either the surface cylinder or the pendant cylinder itself, and using those 2mm hex keys that you would normally clamp onto a ceiling, the luminaire clamps onto the accessory and holds firmly in place. You add the trim plate into the bottom just to finish the look of the product, and then after that you install the pendant part onto the ceiling bracket, which has previously been installed into the ceiling. The RJ45 connectors connect into a barrel type connector, and then the whole stem is inserted into that ceiling bracket. 4 screws hold that in place, and then 2 screws hold and secure a canopy, a decorative canopy over the top, just to finish off the look. Again, those accessory kits, the pendant and the surface cylinder, are available in black, white, and primed. Paint options as standard, and we can also do custom color paint options as well if required. Cat6 cable connectivity. This is something that we chose to do because everybody knows what Cat6 cable is, the type of data cable that's used in networking applications. Again, this is not a PoE networking fixture itself. It is a product that carries power from the F-Drive solution using Cat6. And the reason we say Cat6 cable is because we're looking for a cable gauge of 23 gauge or larger. So the Cat6 is really to do with about the physical size of the conductor rather than any data integrity or anything like that. But literally 4 luminaires can daisy chain together. So in from the F-Drive system, which is in a remote location, and then out of the first into the second, and so on through the 4. And this render here details a nice section of an office space. We have a facilities room or a rack room next door, where we've installed our F-Drive drivers. In this case, we've got some Paradigm equipment in there as well. And those Cat6 cables run up the wall. Typically, it would be in some kind of on a tray or something to dress it up the wall into the ceiling space, and then daisy chains through those luminaires. Another short video here on connectivity using RJ45 connections. The top one is the in, and the bottom one is the out. And again, it does matter. We have put some mechanical or electrical circuitry in there that prevents you from physically adding on more than 4 luminaires, so they need to be connected in order. Then above the ceiling, you can see that those ceiling clamps holding the fixture tight onto the ceiling. The trim plate just dresses the look from the room side, and then RJ45 in and through makes it a really fast and simple method. The nice thing about using RJ45 Cat6 cabling is that in many locations, not all, but many locations, it is possible to install this without the use of containment. You can install just like we see in the picture here in a free air type environment. And that reduces cost of containment, cost of install, labor down significantly when using this system. So something to bear in mind is the big savings that can be realized when using this type of cable infrastructure. All right, we're about halfway through here, so let's pause. We've talked about the Navis product, and we can open up for questions if any have come in so far. So at this point, I'm going to ask David and Al and Dana if they received anything on the Q&A.
Yes, Chris, we have a question about cut sheets and drawings and manuals. Are those already online?
They are online, yes. We have data sheets already in place. We have IES files already in place. So if you wanted to do your own AGI layouts or Dialux layouts, then you can download the IES files from our website. We also have manuals online as well. So the only thing that we're yet to add are our CAD drawings, and our CAD team are busy finalizing those and working on them. We'll be putting those online very soon.
And I have to apologize. I clicked the wrong thing and I deleted a question. We have a question about ball fittings and slope ceiling models for the pendant. At this time, we do not have a ball fitting for the Navis pendant. And we do not have a slope ceiling model at this time.
That's right, yeah.
And Chris, we have another one that just came in. Is there an interface for retrofitting a fixture into a condition where I have 120 volt and 0 to 10 volt?
The luminaire itself is purely a low voltage product and needs to be connected back to the F-Drive driver. This will make sense shortly as we move through. We have a couple of different options in drivers as well. So I think if we go, let's flag that question for the end, Al, and then once we've gone through the driver section, we can see if that's been answered.
Okay. We have several more that came in. Thank you, Kay, and thank you, Mike, for sending these in. A question about setback between the fixture and the trim ring. How much of that setback can the magnets deal with? Honestly, at this time, Mike, you want 0 setback. You want those magnets touching that trim ring. That gives you the best connection possible. And then does the driver, and Kay, your question is, does the driver in the luminaire or in the driver box? Is the driver in the luminaire or in the driver box? I'm sorry for stumbling, everyone. In the RGBW fixture, there is a driver inside of the fixture, and with the fade to warm and white, the smarts or the driver itself is in the F-Drive. Now the color fixture has a chroma card, which is basically for communication. So your white and fade to warm fixtures, the smarts are in the F-Drive, and in the RGBW, the smarts are in the fixture.
Yeah, I'll follow up on that. Just obviously we haven't got to the F-Drive section yet, so some of this is going to become clearer as we go on. But the white and the fade to warm luminaires are very much essentially dumb luminaires. What they have in them is an LED. There's some technology for thermal protection, and there is obviously some electrical product to allow you to make your RJ45 connection to. That's about it in the white and fade to warm product. The clever stuff, as Al said, is all been remoted away into the F-Drive, the centralized driver location. Things like the power supply and the driver cards, all remotely located. That's really good for safety, security, maintenance, etc. The RGBW version of the luminaire has a small daughter board that basically sits inside the luminaire itself. It's not separate to the luminaire, it's physically embedded in the middle of the luminaire itself. Obviously, all considerations given for thermal performance and heat protection and that kind of thing. But even then, there are still major components, and all the power supplies are relocated away centrally into the F-Drive system. So as far as humanly possible, we've removed as many critical components as we can and put them into an accessible location. All right, any more questions from, do you want to cover now, or should we move on and pick up at the end?
Oh, we had a lot come in, but I think we should pick up some of these at the end. There's a lot that quite a bit is F-Drive related.
Okay, very good. All right. Well,
if I can interject for just one quick moment, for our audience, one of the things you'll notice as you're seeing some of these questions coming in is there's a little thumbs up button that sits next to those questions. That's actually a voting button. And if you see a question that you want to make absolutely certain that we answer, that you've seen come into the list, go ahead and click on that. That'll help uptick those specific questions so that we know what's most important for the audience as a whole. We will try to answer everybody's question, but I also want to make sure that people get a chance to vote if they have a question they want to make absolutely certain that we answer. And with that, I'll turn it back over to you, Chris.
All right, thank you very much. Yeah, we often get many questions in these. We'll try and address as many as possible during the session. We're also amalgamating these questions as well. So the plan is ultimately to create an FAQ, and we'll make that available on our website when that's ready and finished. So if we don't get to your questions today, it's really just a question of time, then we'll add those to the FAQ. All right, well, we've talked about Navis, this great new luminaire solution, and we've been noting that this connects to this F-Drive central driver system, but we haven't discussed that. So let's move on to that right now. F-Drive, a standalone product in its own right, but obviously designed very much to complement the Navis luminaire range. F-Drive as a brand is something that is new to ETC. We've developed the name, firstly because, it sounds kind of cool, but also the F refers to as a nod to our Foundry Power Solutions line, and F-Drive sits within the Foundry Power Solutions family of products, and F-Drive is going to be, or the R12 that we're looking at here is going to be the very first product that lives in F-Drive. There are going to be many more over time. We see this as a long-lasting product family that we add to over time. So F-Drive, this is the birth of a new brand, and R12, or R for rack, 12 for 12 bay, 12 slots, is what we're looking at in the image right here. So the R12 is something that you, again, very modular, much like the Navis. You can specify and have configured in the way that you want it to work for a given project. So the first part is you would have the enclosure, the frame, which has nothing in it, essentially, just has a control card. And that control card is the brain of the F-Drive R12. That carries all the configuration. It has all the processing information and all of those kind of electronics. And then you would then select a choice of output cards. And we'll talk about the output cards in just a second. And output cards can vary depending on the type of LED load that you'd like to drive. F-Drive is a 48-volt solution. It's a class 2 or low voltage system. And the nice thing about that is it means there's no inherent shock hazards. So we actually use an external low voltage power supply. We'll show you some details on that in a moment as well. And to reiterate, it means in most locations you don't need containment from the driver itself up to the luminaires. There are some exceptions to that, such as Chicago Plenum, but in many locations around the world, you can just free air the cable from here straight to the luminaire. When you buy this product, there are just blank plates in the front of these outputs themselves. Those blank plates are just held in place using a screw. So the screw is removed, the output card is inserted. So what is an output card? Well, this is an output card. In fact, there are 5 output cards, and those 5 output cards each do something different. So we'll take a closer look at each of the 5 that we're having ready for launch. And the first one we're going to talk about is the CC150 card. So with LED loads, typically they fall into one of 2 categories. There are other types, but the most common types of LED load you're going to see is either a constant current, CC load, or a constant voltage, CV load. So the CC150 is a constant current card up to 150 watts of output. All of these cards have 4 channels on them. So with a fully occupied R12, 12 slots, 4 channels on each card, you're looking at up to 48 individual channels of control. With the CC150 card, this is the card you would use to connect to the Navis 100 fixed white luminaire. And obviously you can use your Cat6, your RJ45 cable to daisy chain in and through 4 luminaires. So 4 luminaires on one single RJ45 cable, and then you have 4 channels of control on a CC150 card. So you can have individual control over each of those 4 luminaires. The clever thing about the CC150 card is it's also possible to dynamically vary the amount of drive current, the LED drive current that's required in order to control a particular luminaire. So if you want to use it using the ETC Navis 100 luminaire, well, that particular product needs 600 milliamps of drive current, and that's what we default the card to. So you can purchase a Navis 100 and an F-Drive with some CC150 cards, and the two are just set up to work together. But if you wanted to use a third-party luminaire or even an ArcSystem Pro Micro, which uses a much lower drive current, you can then log into the F-Drive using RDM or using Concert software, ETC Concert software, and you can change on a per channel basis the amount of drive current that's being used. So you might have channels 1 and 2 at 600 milliamps, but then, you know, I also want to use a couple of those micros, ArcSystem Pro 1-cell micros, and I'm going to set those two channels down to 200 milliamps. And that allows you to drive different types of LED load, either from ETC or from a third-party manufacturer. Each card, 50 watts maximum per channel, 150 watts maximum total per card, and up to, I think it's 1500, maybe 1800 watts for the total rack itself. The CV150 is the constant voltage version of the card. This is typically used for things like LED strip lights, or tape light or LED rope light. Linear LED lighting very typically uses constant voltage technology rather than constant current. So at ETC, we don't have a luminaire that uses CV other than our arc lamp, and we have a separate card for that I'll talk about in a second. But if you wanted to install LED strip light into a room as accent lighting, you could also insert a CV150 card into an R12 rack and power it using the CV150 card. Again, 4 channels. It's fixed at 24 volts, which is the most popular, in our experience, the most popular kind of constant voltage technology that's used. Some CV loads use 48, some go down to 12, but most use 24. And again, over time, using a modular system like this, we'll be adding more cards to the system. So keep feedback coming in. If you see something that you would like to use, we don't have a card to support it, do let us know on that, and we'll add that into onto the list. The next card we have is a fade to warm card. It's specifically been designed for use with the Navis 100 fade to warm fixture. So this is the FTW 150. Again, supports up to 4 Navis 100 luminaires, the fade to warm luminaires, and it's preset to a drive current of 450 milliamps. So that's what it's set up to do. It's set up to drive those FTW luminaires, and it contains things like that fade to warm temperature scaling technology that we were talking about when we were looking at the fade to warm luminaire. It allows us to dynamically change the performance of the fade to warm threshold in the fade curve. And that's why this one operates using a different output card itself. The next card we have is the Chroma 150, provides 48 volt power and data up to those RGBW luminaires, again, specifically for use with the Navis 100 RGBW luminaire. And we talked about having that very small driver card in the luminaire itself. So what this card is doing here is providing the low voltage power and the data stream up into that low voltage driver card at the luminaire itself. Again, up to 4 fixtures in total, and you can have individual control over each of them. And the last card we're going to make available is the Arc Lamp 150 card. Now, this is kind of a replication of the existing Arc Lamp 150 wall mount driver. And so if you have a project where you have some small chandeliers or wall sconces and you want to power those using an F-Drive R12 rack, then you can have up to 4 channels of up to 8 arc lamps per channel using this particular card. So what all this means is you can combine these different card types into one R12 rack. The cards simply pull out and insert into whatever order you would like them to be in the rack, and it means you can control Navis 100 luminaires, you can control third-party luminaires, you can control constant current loads, constant voltage loads, arc lamps, even different color changing Navis 100 product as well. And so you just specify the output card that you need, insert it into the rack, and then configure the parameters on each card during the installation process. So we've made these cards hot swappable. What that means is that if you imagine you have a fully loaded R12 rack, 12 cards, 4 channels per card, up to 48 Navis 100 luminaires, for instance, in a particular room, and those 48 luminaires are lighting a large room, and if one of those cards needs replacing, or you need to change the type of load that's in the card, in the rack itself, you can actually replace those with the rack energized. Remember, we're only talking low voltage 48-volt system here. So you can use the thumb screws, remove the output card, insert a new one, and you don't have to turn off all the lighting in that particular space to do it. The control card hosts a micro SD card, and that's what contains the firmware for the product and also contains the configuration for the product. The nice thing about the firmware living on an SD card is it means you can take the SD card out. Again, you can do this with the rack energized and the rack will hold last look. You can drag the new firmware files onto the SD card, insert the SD card, insert the output card into the rack, and then the rack itself will then update all of the individual output cards firmware automatically. It will also go over the Cat6 cable and update the firmware in the RGBW luminaires automatically as well. All that's an automated process, really fast and really simple. Configuration is equally simple. We take the new version of the ETC Concert software, and there is a configurator, an offline configurator that allows you to take the SD card from an R12, insert it into a laptop, make all of the changes that you would like to make on a per card or per channel basis, and then you can insert the fully configured SD card back into the rack and have it all done in one hit. It also means you could do those configuration changes off-site, offline, before you even get to site, and then just insert SD cards into R12s that have already been installed. And that's a really fast system as well. R12 uses DMX to DMX input in order to operate. So we have many DMX gateway and control options available, as you know, from ETC. So DMX into this is fully RDM compliant. So as many RDM parameters that we can change using the RDM protocol we've made available. Some of the more complex or proprietary features such as fade to warm temperature scaling, you can only really change using the configurator within Concert. But again, that's such an easy system, and that's okay. Take a look at the back of the product itself. You can see a various different connectors here. We have RJ45 connectors on the back, one per slot, and obviously you would use those when using the Navis 100 luminaires. So a single Cat6 cable from the back of that rack up to the luminaires, and then daisy chain the luminaires from there up to 4 on a card. If you're using the other option you've got, even if you are using the Navis 100 luminaires, is you've got the option to run your own cable, or if you've got existing cable in the building, obviously you'd need to home run it on a per fixture basis, but you have the option to be able to use a header that fits onto those orange connectors you can see on the screen. That allows you to terminate your existing cable. You also use those orange headers if you're using constant voltage loads. Constant voltage loads, things like LED strip, LED tape, or also the arc lamp card and the arc lamps, which is technically a constant voltage system as well, can only be connected to R12 using the orange headers. We disable the use of the RJ45 connectors when using constant voltage loads, and that's to do with the amount of current that typically gets used with those constant voltage loads. You wouldn't be able to get any meaningful length away from the rack when using constant voltage. So orange connectors only, the headers for thicker gauge cable when using constant voltage loads or your own building existing wiring, and the RJ45 connectors for use with Cat6 23 gauge cable or larger, and that's ideal for using Navis 100 systems. I mentioned it was a DC input power from an external power source. We'll take a look at that in just a second, but the DC input goes into the black connector, DMX in and through connectivity, and then we have the green connector in the top right. This does two things. Firstly, it allows you to connect a remote switch. So if you just wanted some kind of test switch or panic switch, or some kind of connection from a fire panel, for example, where you could remotely turn on lighting, then you can connect in to the green connector here and use either wet or dry contacts. I should point out this is not an emergency listed driver. It does give you the option to be able to turn things on remotely, but it's not listed for use in emergency applications. So that's something to bear in mind. The other thing this green switch will do is allow you to pass through the 48-volt main supply. So power comes in from the external power supply, obviously powers our luminaires in the driver itself, and it also passes out the 48 volts. And we would insert that into a separate driver that is emergency listed, and that will allow us to do a cohesive lighting solution with an emergency backup. And more on that extra device in a couple of slides' time. So here's the external power supply we were talking about. It's actually a product that's manufactured by Meanwell, but we support the use of it for use with F-Drive. It consists of two parts: the power supply frame itself, which is this 1U 19-inch rack. In this case, we're showing it with one inserted power supply module. This one module will support the entire fully loaded R12 rack that we were just looking at. So in this case, if you wanted to add a second power supply module, you remove a blank plate, you insert a second power supply module, and now you can control two fully loaded R12 racks. Obviously, you could insert a third one there as well. You could also use, rather than powering two fully loaded racks, you could use a second module as a backup to the first module. So if one power supply module went down, the second one would seamlessly take over as well. So a couple of good redundancy options there. On the back of the power supply frame itself, we have a positive and a negative output for our DC 48 volts. That's what physically connects to the R12. And at ETC, we've produced these really nice busing kits. And these busing kits allow a much easier termination of the DC output. And it also provides the harness, the physical piece of wire with the DC power input into the R12 rack. So when specifying the system, we require the R12 with the output cards and the frame. We will then require the power supply frame and the power supply module. And we also require a busing kit as well. The busing kit gets supplied with a plastic cover that we just put over the top. Bear in mind, this is 48 volt DC. There's no shock hazard here, but just to keep things neat and tidy, we provide it with a nice plastic cover just to prevent anything metallic falling down the top and to clean up the rear end of the power supply frame itself. The other thing you can do with our busing kits is you can bus up two power supply frames together. Bear in mind there are 3 power supply modules in each frame. So now we're looking at connecting the output from up to 6, because there are 2 frames, 6 power supply modules into one single positive and negative output. So now with this system, you can provide power for up to 6 fully loaded R12 driver systems. You could even add a third frame and have up to 9. 9 is the absolute maximum, but 9 combined bussed up power supplies, providing a combined power supply for up to 9 F-Drive R12 systems. It provides a really nice balanced power output in the genuine sense of the word, because it's all tied together. Again, with our larger busing kits, we also provide those nice plastic covers over the top as well. So here's a look at the installation example, all standard 19-inch rack stuff. So the F-Drive R12 is a 2U rack height device, and the Meanwell power supply is a 1U rack height device. So if we do the math here, it actually means in 7U of rack space, you could have a totally lost my my math here. You could do 3 R12. There we go. I haven't had enough coffee today. You could do 3 R12 drivers with one Meanwell power supply frame with 3 modules in it, and that's 144 channels of architectural lighting using Navis 100 in 7U of rack space. It's an incredible amount of density for the size of the drivers, and again, all this will be in an accessible location. Here's a look at the back of that driver solution. RJ45 connectors powering the Navis luminaires. You've got the orange headers there being used to connect some LED strip and some arc lamps in this case, and you can see the connectivity of the power supply itself. I have a small video which will show this in a little more detail here as well. So this is the installation in that rack. In this case, we've got a second power supply module to provide some redundancy in case that first module was to go down. Standard rack hardware, just installing the product into a rack. And the cards themselves insert and remove without tools. So it's a thumb screw to remove the control card, just literally slides out. There's the micro SD card carrying all the firmware and the configuration for that particular R12 rack, if we had to replace that, it's literally as simple as pulling one out and putting another one in. We also vibration test these as well to make sure they don't fall out when they shouldn't. And then the control card inserts thermal screw to tighten it back up, and that kicks everything back into life again. Output cards remove in exactly the same way. You can see us removing an output card there. You will also notice different colored strips. So we have a green stripe on there for a fade to warm card, a purple for the chroma card, a white one for the arc lamp card. And those colored strips relate to the color of the label on the Navis 100 luminaires as well. So if you're using an RGBW Navis 100, that has purple label on it, and that corresponds to the purple label on the output card, just to make things easier from an installation point of view. We're now looking at the physical installation of the power supply and the R12 rack. So we connected the output cards to that busing kit on the back, and then a simple connector into the R12 itself. The power cord, we have a few options on power cords depending on where you are geographically as to whether you'd want perhaps an Edison connector for the UK or a 16 amp C-form plug in Europe, or also we offer a Schuko plug as well for other parts of mainland Europe. So you can choose the type of power input cord to a locking C19 IEC connector, and we use the locking one to stop them being inadvertently pulled out the back of the rack as well. Then we connect our loads. Now we have these blue RJ45 Cat6 cables. These will all be running up to our Navis 100 luminaires, and we've already plugged in those headers into the orange connectors on the back of the rack here as well. We've actually, as standard, we ship out with 8 position headers just to make life a little easier in installing them, but you could use the 2 position ones as well if preferred. We have LEDs on the front showing you the status of individual output cards and any errors that may be there, or whether there's active output on a particular channel. So just to recap, how do we specify an F-Drive R12? The first thing we do is we select the enclosure, which comes with that control card with the brains in it and the micro SD card that carries the configuration. You then select as many output cards as you required, and that really depends on the type of LED load that you're using, and you populate the R12 enclosure with those output cards. You select a power supply frame and at least one power supply module to go in that frame. You then select your choice of busing kit, and if you're using just one, whether you're using one power supply frame with one R12 or one power supply frame with 2 R12s, etc., or 2 power supply frames with 4 R12s, you select the busing kit that is appropriate for you. Then you select your choice of power supply input cord, and again, this is whether you want a 16 amp plug or a Schuko plug or an Edison plug. Once you've done these steps here, then you have a fully cohesive working system, and we'll obviously help you with this as well. It's not too difficult to select to put the system together, and I think once you've done 1 or 2, it will all make sense. But obviously, we're here to help if you need any additional guidance. The other product that we are wrapping up development on is the F-Drive W1 and W1E, and W meaning wall mounts, and the 1 is a size identifier. Now, imagine one of our R12 output cards with the 4 channels on it. Insert that output card into a metal box, put a local power supply into the metal box. That's exactly what we're looking at here. So the intention of the W1 is a smaller wall mounting 4-channel driver box that allows you to control up to 4 Navis 100s or 4 other third-party luminaires locally, where you don't perhaps need as many channels in a given location. The other thing we have with the W1 is an emergency version. So the W1E is a emergency listed UL 924 in North America, also listed for emergency use in European applications, so listed for CE emergency use. This allows us to take a sense input from our green connector on the back of the R12 and insert that 48 volt sense into the W1E. And what that is allowing the W1E to do is function as a normal 4-channel constant current or fade to warm or constant voltage driver. And then if that sense input goes away, then it knows that there must be an emergency situation, and it forces the outputs of the 4 channels in the W1E to full, and that gives you your emergency egress lighting. This product is available with inputs up to 277 volts, so 100 volts minimum, 277 volts maximum. And the sense input that we were just talking about functions between 40 and 300 volts AC or DC. So you can put the low voltage sense input from an R12 at 48 volt DC, or you could also use this as a 277 volt AC sense input as well, all in the same product. W1E is fine, just going through its final compliance and testing at the moment. We expect this product to be ready to go by the end of May, subject to wrapping up a few bits and pieces. Things are a little slow at the moment for obvious reasons. Pricing is ready, the product is launched, and I'd encourage you to speak to your local ETC rep or regional sales manager, depending on where you are in the world. For any reps on the call, this product will soon, if not already, be appearing in ETC Select in North America. And the Navis and F-Drive system will be provided as a quoted solution. What that means is that we will put together a system for you, working with your local ETC sales channel, in order to make sure that we have all of the right parts and pieces to make a working system. But please talk to your local ETC sales channel for more information on pricing. Website is up and running. This is a screen grab of the current website. There is a link on here at the bottom, but you can also find this just by going to etcconnect.com. As soon as you get to the homepage, we currently have a big banner across the top of the homepage at the moment that allows you to link straight to the Navis and F-Drive system page, and you can see this information for yourself and download any information you need. And with that, it brings us to the end of the formal part of the presentation. And once again, I'll open the floor here to any questions, and we'll stay around really for as long as is necessary. Feel free to hang around for as long as you like with questions. If you are running tight on time and need to drop out, we understand that too. And I'll open the floor again to David and Al and Dana in case there are any questions that need to come through.
Chris, thank you very much. This has been fantastic. We do have a number of questions that have come through. I'm going to start back up at the top of the list to look for things that we hadn't answered. I know Alan and Dana have been looking down at the more recent questions that have come in. One of the first questions that I'm seeing, and I think you answered this, but I think it's worth asking again, are cut sheets, drawings, and manuals already on our website?
They are, yes. In two separate places, we have a product page for F-Drive and a product page for Navis. Again, you can link to all of those from that banner on the homepage. But yes, all of the above, with the exception of drawings that will be added soon. The formal CAD drawings will be added in the coming days, but everything else is there now.
Fantastic, thank you. Is there an interface for retrofitting a fixture in a condition where I have 120 volt and a 0 to 10 volt device?
Yeah, so that question was earlier, and I think the way you would do that now, ultimately, Navis 100 needs to connect to one of our driver cards. This is a low voltage system. So the way you would do that if you just have a 120 volt local supply is probably take the W1 driver and put that locally to your 120 volt. Unfortunately, we don't have 0 to 10 volt. So we would need a way to get DMX into that W1 driver, which would be the only real challenge, I guess, with that. But yeah, using the distributed W1 would probably be the easiest way to do it. Alternatively, you could use the line voltages, the mains conductors that are already in the ceiling, and assuming, depending on the complexity of it, home run them back to the R12 location and use those headers rather than the RJ45 to connect the existing cable into the back of the R12.
Cool. I can picture that in my mind. This was a really popular question, got a lot of votes. What happens when the contractor accidentally connects a fifth fixture to that Cat5 line?
Good question. Nothing is the answer. It kind of depends on the fixture. The fade to warm and the white luminaires have an electrical scheme on them that physically stop you from adding a fifth fixture. So very difficult to explain audibly, much easier to draw out, and the detail is in the manual, but I'll try and describe this as succinctly as I can. The first pairs, there are 4 pairs in a Cat6 cable, and the first pair is always the pair that is used to power that particular luminaire. So what the luminaire does on the output side, on the through connector, is it shifts the pairs of cable up one slot. So pairs 1 and 2 power the first luminaire, the first pair of conductors powers the first luminaire, the second pair of conductors powers the second luminaire, the third pair of conductors powers the third luminaire, the fourth powers the fourth, and then there is nothing left to power the fifth. So if you connect to the fifth, it just doesn't physically have a connection to the Cat6 cable in order to operate. So nothing is the case in that. If you try to add a fifth RGBW luminaire, then we have overcurrent protection, and the R12 itself, the card in the R12, would just switch off the output and give you an error.
Great answer, thank you. Can the F-Drive be interlaced into a standard DMX512 system? If so, what channel count would an R12 take? Assuming 48, however, how many fixtures would the DMX controller see?
You have, it depends on the mode. So if you're using the RGBW card, then up to 5 channels per fixture is the answer. So obviously 4 fixtures on a card, that means up to 20 DMX channels per chroma card, we call it, that drives the RGBW luminaire. And that would give you full direct control, so intensity, red, green, blue, white. But we also do a 4-channel mode, which removes one of those channels, so it's IRGB mode. And if you put all of those on, RGB and I to 4, that's what gives you your calibrated 3000 Kelvin appearance at the fixture end. So 20 maximum, could be as low as 15. Is that right? 16. But the fade to warm and the white luminaires are all 1 channel each. So 4 channels on a CC150 card, 4 on a CV150 card, 4 on an arc lamp card, up to 20 on a chroma card.
And you'd see all of this within concert when you went to connect up to the unit and look at it, correct?
Yeah, you would. I mean, with concert, we are working on giving you full live direct bi-communicational, because obviously this is a DMX RDM device, not a networking device. So the way to do it is to pull the SD card from the control card, insert that into your laptop, and then you then use the concert software, and there's a configurator within concert that graphically displays a simulation of all the slots in an F-Drive and allows you to bulk update or individually update different parameters. It's actually really fast and really easy to do it. And the benefit of that is that you can do all that configuration work before you even get to a site to insert those SD cards and have the system up and running very quickly.
Perfect, thank you. There were a couple of questions that came in specific about commissioning this product, and some of them got answered inside of the chat, but one of the comments that came back is the entire system considered to be user commissionable? Go ahead.
We make this a systems product. This is a system product. With it, we'll add some services in there to provide system configuration, much like we would do with any kind of ETC systems quoted product. That's the way we're going to do this for the time being. This is kind of a new approach in terms of installing this type of technology, and we just want to make sure that when deploying a system, we are meeting and exceeding the requirements of the customer. Over time, it may become apparent that there are easier ways to do it, or we don't need to do that, and we can adjust that policy as we move forward. But at the moment, it's a systems quoted system, and we'll obviously put appropriate services on there to make sure that it will be commissioned accordingly.
Perfect, thank you. I see a couple of comments that have come in, but they aren't necessarily questions. Allyn, Dana, have you seen anything that we should, did I miss anything? Are there any other questions that we need to answer?
I am fast and furiously trying to catch up on all of these questions. There are so many good ones. There were a couple that I wanted to get back to highlight. Mary, you asked a question about, or stated that, with the RGBW version that, it's a 5-channel DMX fixture, but documentation on the website calls this out as a 4-channel. I need to get back and double check the website, but we have RGBW as the colors that, as what you can control there, but we have the intensity. That's where the 5th channel comes in.
It depends on your mode as well.
Because if you're an IRGB Direct. Yes, the mode, there's two modes that you can go into, and one requires this, the other does not. Thank you, Chris. There were a couple other ones. I'm addressing a hot swapping question. We designed F-Drive, and this is the user put a question as their username about, is there an interface for retrofitting a fixture? Your question is, with hot swapping, isn't there a real possibility of damaging connected loads or overloading a card? We specifically designed all of our F-Drive driver cards to be hot swappable. So we have engineered these to protect against overloading cards and damaging the loads on the other end. This was one of the key design features of our product. Chris, how does that sound?
Yeah, I mean, there are some very valid questions when using extremely low voltage or low forward voltage LED loads, and there is a limit. We have some electrical characteristics that mention what the lowest forward voltage loads you can use. I want to say on the constant current card, it's something like 10 volts forward voltage is the lowest you could do, and anything within the operating parameters is going to work fine when connected under load. If you try to connect something with too low a forward voltage, then the system would actually identify that as an overcurrent and would close down the circuit to avoid any damage. So the answer to the question is, as long as you're following the operating ranges within the of the particular card you're using and the type of LED load that it supports, then you won't have a problem.